Hello friends, welcome to Core Basics Coding tutorial. In this tutorial we are going to learn about multiprocessing pool. Here I have a program which is calculating the square of all the numbers in this array. So I have this array, I'm going through the array here, and then I'm calling this function, which is just a very simple function calculating the square of the number. And I append the results and I'm printing the results. So if I run this program, the program works fine, absolutely no issues. Now let's look into internal details on how Python will execute this program using the CPU on your computer. So let me show you our diagram here. Here, this big yellow block is your CPU and it is having 4 cores. These cores are nothing but processing units present on your CPU or central processing unit. Nowadays, most of the computers comes with multiple cores. So it is very likely you will have multiple cores. You might have 2 cores or 4 cores based on the kind of configuration you have. But let's assume you have 4 cores here. When you execute that program, your OS is gonna select one of the cores and this core will execute the entire program. Now the problem here is that you have 3 other cores sitting idle. Now when you're running multiple programs on your computer, most likely they will be doing some work, but let's say if they are not doing some work, then they are sitting idle. Okay, now this program is pretty simple. You have 5 numbers and you are calculating square, so it is not very computationally intensive. But if you are doing heavy image processing or heavy computation, then giving all workload to one core might not be a good idea. I mean, if you can somehow parallelize your work and divide this input into these multiple cores, it would be better. Okay, so I'm going to show you how you could do it. So let's say you have input, you have 4 cores, and somehow if you can deploy your code on all the cores, and then let's say if you can divide your input between all these cores. So here I have 1 2 3 4 5, so I just divided all the numbers between the cores. So I have more numbers than the number of cores, so this guy is getting 2 numbers. Okay, but essentially you are dividing the work equally between all these 4 units. And let's say they calculate the results, and here are my results, and in the end you aggregate those results back into one output. Okay, now difference between this approach and the previous approach is that here you are utilizing all the cores. Of course you have to do some division of work and then aggregation, but you are utilizing all the processing power that you have on your computer. Okay, this is called parallel processing, and this process of dividing the numbers, the input between multiple cores, is called map, versus the process of aggregating these results back is called reduce. So if someone talks about map and reduce, this is what it is. It's not a rocket science, pretty simple concept. Map means you divide work between multiple units. Reduce means you aggregate those results back into one common or single output. Okay, so let's do this, exactly this thing, using multiprocessing pool. Okay, so I'm going to exit out of that presentation and I'm going to import pool. So from multiprocessing, import pool, and here I'm going to create an object of pool class, and I will say then the method that you want to use is p.map. When you do map, it will divide the work between multiple cores. Okay, so the first argument is a function that you want to execute, which in our case is f, and the second argument is your array input. Okay, now this alone is gonna divide the work equally between all available cores on your CPU. Okay, and it's also gonna give you back the result. So see, now my program is pretty simple. p.map array, and this function results the aggregate result back. When I run the program, I get the same output. Okay, although visually I don't see any difference, internally it has divided the work equally between the cores. Okay, now let me show you how it can speed up the process. So if I'm going to measure the performance here, it's not gonna be very different because the task that I'm doing is quite simple. So let me do some heavy lifting. I'm just going to make something up. So for x in range 100 sum plus equal to x cross x and sum. So I'm just making something up. Okay, and this goes back, and I'm not going to print result because it's gonna be too much. So here, okay, so here let me do this. Instead of the array, let me supply huge array with, like, let's say 10,000 elements. Okay, and just to make it even more computationally intensive, I'm going to increase the range over there, and I'm going to measure the performance of this program. So let me import time so that I can measure the performance. So t1 is equal to time. So when you do this, it's gonna take the current time, and at this point, by the way, when you do pull, you have to do pull.close and p.join. That way this will return only if all the workers which you created using this function are done executing their code. Okay, now let me print the, so here what I'm saying is pull took, how much time did it take? Well, pull took time. So here I'm again taking the current timestamp and then subtracting t1. So this way I get the time difference between this line and this line. So you're measuring the performance of your pull code. Okay, and in the second section of my code, what I'm going to do is I'm going to do this in a single loop. So for x in range, same number, so I'll just copy paste, and then I'm going to, I need to aggregate the result. Okay, so result is this, and result dot append f dot x. Okay, pretty straightforward. And then I will say print serial processing took. So this is serial processing time. Now I need to take another timestamp here, t2. Okay, fairly straightforward. This time is the time between this line here and here. So I'm measuring performance of this code versus this code, and I'm comparing them. Let's run it. So you can see here that pull is taking less time. It took 0.51 second, which is like half second, and this took almost double, which is almost 1 second. Okay, you can see it. And as your processing load increases, let's say I add 10 here, as your processing load increases, pull is gonna perform better and better. So pull took 2.83, and this guy has not returned yet. We'll see how much time it takes. It's gonna take considerably long time. So you see 9.5 seconds versus 2 seconds. So using pull will speed up your processing time because, as I said, you're dividing tasks your work between multiple units. Okay, next thing we want to talk about is Pull has an argument called processes. So processes, if you just say processes equal to, let's say, 3. Okay, if you do that, it's gonna create only 3 processes at the same time. So again, for the output you don't see any result, but internally at a time it will create only 3 processes. Okay, so that was all about Pull in Python. I hope you are having fun time learning multiprocessing and multi-threading in Python. Please don't forget to subscribe to my channel, and also remember to listen to my Python multiprocessing playlist. Okay, thank you very much.